Okay, my name is Klaus Darilion. I'm working for nic.at, and we also have a Anycast product we sell. It's called Code Zero Anycast DNS, and that's like a story where which problems we recently had and how we solved it. For the executive summary, it's like 3 different technologies or parts. Like the first is BCP38, that means validation of source IP addresses. The second thing is a Anycast local node, which is direct connected only to an internet exchange. And the third thing is asymmetric routing. And if all these 3 things happen at the same time, then you might have a problem if you are an Anycast provider. And we had that problem, and I'll show you a solution for that problem. So I shortly describe the 3 things. So PCP38. If you have your server with some internet service provider, you get usually an IP address from that service provider. And with that, on the right side is our server. We can use the IP address that was assigned to us by the ISP to connect our server to the internet. And actually, ISP should do filtering that only if we use IP addresses that are assigned to our server are allowed to send traffic out to the internet. If we, for example, would spoof the source IP address, like using like 888 as source IP address, the ISP should detect that and should block that packet so that it's not routed to the internet. This is what's called what BCP38 is about. It's also called reverse path filtering, or just prevents that clients can spoof the IP address of somebody else. And there are already server providers which do that. There are, of course, providers which don't do filtering, but there are many good providers which do filtering. The second thing is a local node. So I have to skip here some slides for time reasons. The important thing is if we have an Anycast name server, we have 2 types of IP addresses on that name server usually. We have a unicast IP address for the management of the server, to send us for the zone transfers, for the monitoring, and so on, for the normal management of the server. And on the other hand, we have the IP addresses for the Anycast service. So the Anycast IP addresses are used only for the DNS service, and the unicast IP address is used for the management of the server. So in our setup, when we have a so-called a global node, that means that we have an internet provider which gives us transit for the DNS service and for the management. That means we use a single network interface card, and we have the IP addresses, the unicast and the Anycast IP addresses assigned to that interface. So we can use for the management and for the Anycast DNS traffic, we use the same interface. And of course, our provider, like nic.at, like Kate before, is one of our providers. They know what our unicast IP address is because they assigned it to us, and they also know our Anycast IP addresses because we announced them with BGP. So they know what are our IP addresses and they can filter on it. A local node is a node which is where we don't have global transit for the Anycast DNS. Often some internet exchanges, mostly smaller ones, they ask us if we want to put a server there. They provide us free co-location and IP connectivity for the management. And they also provide us connectivity directly to the internet exchange. In that case, the server usually has 2 network interface cards. So one is used with the unicast IP address exclusively for the management of the server, and the second interface card is directly connected into the internet exchange. Is only used for the DNS routing. So that means that we can send DNS traffic only from and to the internet exchange. So, and the third thing is asymmetric routing. I first start with the symmetric routing. In a typical peering setup, for example, this is a real case we have like in Tampere at the Trax Internet Exchange in Finland. We are there peering with Elisa. So Elisa is announcing their prefixes to us, and we announce our Anycast prefix to Elisa. So, and usually when there's like a packet coming in, then it's going over the internet exchange because of the peering, and we can send back the response also over the internet exchange. But of course, this only works if the source IP address of the DNS request matches one of the routes we receive on the Internet Exchange. For example, sometimes Elisa sends us DNS requests with a different source IP, where the respective prefix is not announced to us on the Internet Exchange. So there are in that case, what shall we do with the response? Where shall we send it? Because we don't have a route for that source IP address where the request was coming from. So in a typical Linux setup, if you don't have a more specific route, the default route kicks in. So that means the traffic would go outside on the management interface to our local host. So in that case, it's we have the management from Trax itself, and then we send the DNS response out on the management interface. And of course, if they do BCP38 filtering, they only allow packets where the source IP address is the unicast IP address of this management interface. So what happens? Our DNS response gets dropped. BCP38 filtering. And this happened to us with how do you detect it? Because clients complain, hey, I don't get a response to my request. So we have to find out. It's very difficult to find out because if we tell the customer, usually we tell the customers, make a dig lookup with plus NSID, we see which location it hits, but he doesn't get a response. So it's difficult to find out where he gets routed to. Also, the trace route somewhere stops in between because it's really difficult to find out. So more or less, we have to start TCP dump there and just watch out from the source IP addresses where the client complains to find out which node it hits. And so we found out what the problem is. So how can we solve this issue? One thing would be, like in that case, if we tell our local host, just disable BCP38 filtering. So of course they will not do this because they do it for good reasons. Or of course, like they implement like a static whitelist of the IP addresses which we have. So sometimes this is possible, but sometimes it's not possible. So they could do it, but they don't want because they then need manual configuration, and usually they have everything automated. Or maybe it's not our local host, but the provider of this local host does the filtering, so it's getting complicated. A second thing is, okay, we need to buy or bag for transit for the DNS service. Of course, that's extra costs maybe, or we have to buy and ask everybody on the peer on the Internet Exchange, can you please donate us some transit? And of course, it takes time. And the third thing is, which came to our mind, is okay, we have global nodes where we don't have problems, but we have only problems on the local node. So why can't we just forward the traffic to one of our global nodes, and then we can send the response out to the internet without any problems? And we implemented now a combination of 2 and 3. So back to the example with the Internet Exchange in Tampere. So if now Elisa sends us a DNS request from a source IP address which is not on the Internet Exchange available, so asymmetric routing, the response is not sent directly out on the default route, but we have created a GRE handle to one of our global nodes. So, and we just have a default route that points into the GRE tunnel. So if the Anycast DNS traffic doesn't have a more specific route, the default route kicks in. The response is sent into the GRE tunnel. It falls out on some global node. And on the global node, the packet is decrypted and sent into the internet and back to Elisa. So, of course, this gives us potential additional delay because if the request is coming from Finland, we go back to Amsterdam to our global node and back to Finland. But it only affects a part of the traffic, like only like 2 or 3% is affected with asymmetric routing. And sometimes it's not even that bad. For example, in that special case, this source is not in Finland at all. It's somewhere in Sweden. So it's anyway going a circle around. So it's not that really that we have had much additional delay. So how you can implement this on the Linux? Their idea was actually from Alexi from the Trax Internet Exchange to separate the routing on the Linux server for the management and for the DNS traffic. So we use the default routing table only for the management traffic, and for the Anycast DNS traffic, we use the routing table too. So what do we have to do? We are using FRR as a BGP daemon. So we have to create a route map which tells the BGP daemon to feed all the routes learned on via BGP, not in the default routing table, but into table 2. That's where we see a simple just set table 2 in the route map. Then the second thing is for the Linux routing, we have to define a policy-based routing. So we define a policy rule, which tells us, so that's the net plan syntax for the routing policy. If the source is an IP address from our Anycast prefix, use routing table 2. That's more or less the all we have to do. Of course, we also need a GRE tunnel. So that's the net plan syntax for GRE tunnel, also very easy to set it up. In our case, we use IP version 6 for the GRE tunnel because on some nodes we don't have IP version 4 IP addresses, but we always have IP version 6. And of course, we need the default route to feed into the GRE tunnel. In the beginning, we had the default route done with Linux, but now we're using also the FRR daemon for the static default route, because that way, if we receive a default route on the internet exchange from some provider which can give us transit for free, then the BGP default route overrides the static GRE default route, and we automatically have better routing. And if the peer doesn't send us the default route anymore, we automatically fall back to the default to the static default route into the GRE tunnel. So that way, we always have a solution that works. And maybe the last thing is for the remote, how to define the remote, because which local global node shall we use? Shall we use like from Finland? Shall we use Amsterdam or maybe Frankfurt or Warsaw? And what if this server is on maintenance? Then the GRE tunnel is down and we again have packet loss. So we, as Anycast is our business, we also use Anycast for the GRE tunnel endpoint address. So we announce we have a dedicated prefix which we announce only on our global nodes. So for the GRE endpoint on the local node, we automatically end up by the nearest global node. And if that global node is doing some maintenance, we automatically get rerouted to another global node. Yeah, so the summary, we have an Anycast GRE tunnel from our local nodes to the global node. We have a default route into that GRE tunnel, so that in any case, if we have asymmetric routing and PCP38 filtering, we have always a working solution. We send the response into the GRE tunnel to some global node, and then we don't have any routing problems. And optionally, that can happen also sometime later if we find a friendly peer on the internet exchange, which gives us a default route for the transit of the asymmetric routing. Then we can add that anytime later, and it will automatically be used because in our setup the BGP received default route has a higher priority than the static default route into the GRE tunnel. So that was when we first experienced these issues. We already thought about, is it really worth like having local nodes, because it's so complicated every time. Every internet exchange is different. The setup is not homogeneous anymore. We have to make workarounds for every node. But at least we have now found a solution for the problems with the asymmetric routing and the packet loss. And so we still keep our local nodes running. And if somebody with the internet exchange here wants a local node, so you can please approach us. And maybe for comments, if there's other Anycast providers with local nodes and they have experienced the same problem, I would be interested in how they solve this problem. Thanks.
Thank you, Klaus. Questions?
Hi there, it's Joe Abley, Cloudflare. At ISC about 20 years ago, we started doing Anycast with froot. and it was we then, so I'm using we now. I don't work there anymore. And I wrote a document, and it included this concept of global nodes and local nodes. And the ISC, we used no export to control the propagation of the prefix for the local nodes. And I said it in the chat. In hindsight, this is a terrible, terrible idea. I think the way that you deal with local nodes cleanly is don't ever have any local nodes. Assume every node is a global node. And in fact, what you did is you've made your local node in name a global node by allowing it to serve the whole internet, which is the correct thing to do. I think if anybody does have local nodes, don't interpret that word as meaning anything to do with routing. The routing for every node should be the same, even if you call one local and one global, because otherwise you'll run into this kind of problem.
Yeah, that's what we found out. The hard way, unfortunately.
Hello, Jacob Zach from Sierra. So we've seen this a lot. It's a real problem. Used many of the same solutions you went with as well. But we've found, we ask ourselves the philosophical question is, are you doing the internet and or that network or BGP pair a service by working around their incompetency and or mistake? So we found that if we produce reports and give those reports to the Internet Exchange Point, they are generally very keen to track those things down because that's adding value to the Internet Exchange. And, it lets everyone know that the other peers are paying attention. It keeps traffic routing because if they're having that problem communicating with us, they're also having those subnets having a problem communicating with others. So I love the presentation. Everything you're doing is right. It's a real issue. But there is an opportunity there to inform and notify and actually make that routing ecosystem healthier.
We also had the discussion. So we tell them to do avoid asymmetric routing. We have the peer to make everything correct and announce the prefixes. And I said, yes, that's that would be the better approach. But I need a working solution now.
Yes.
Sending emails, talking, describing takes sometimes it takes weeks until you find the correct person at the peer. So it will not stop us to tell people that there is maybe a problem. So, but if it's only like a few, like 2 or 3 packets per second that are routed with our tunnel, like I don't want to have the work and to contact every peer and tell them what they're doing wrong.
Yeah, you're 100% right, and that doesn't scale. So I would agree entirely. But an automated report that just looks on traffic on that management interface that it's not expecting to be there. DNS responses, source port 53 outbound on the management interface, and just dump that directly to the IX and let them handle it because they have much better relationships in their local communities than you do.
Yeah.
So, thank you.
Hello, Peter Thomas in DESEC. So I assume that this is not a report from like 15 years ago, right? It's reasonably recent. And you've probably done this for a while and have some experience. So I'm wondering why this only showed up now, so that it was actually a problem that needed fixing. You said earlier that it was 2-3%, which probably should have shown up much earlier. So I wonder if I misunderstood the prevalence of it. I know you just said 2-3 packets per second, so I'm not sure when it showed up to what extent, pretty much.
So on the 2-3 packets per second can still be like 2 or 3% if it's on a local node where we don't have much traffic.
Okay.
For example, the Trax Internet Exchange in Finland, there are no big cloud providers there, so it's really like a smaller local one. So the numbers can be correct. And why? So and sometimes we don't see it. Like we have a global Anycast monitoring. But if it doesn't hit that node, and if it's not like affected, if the probe is not affected by the asymmetric routing, we will not see it in the monitoring. So we really have to wait until some customers or some customer of a customer, whatever, complains, and we can find it out. So that's why I think for a long time we haven't detected it. Once we detected it at the Trax Internet Exchange, we were eager and watched out. Okay, does it happen on other internet exchanges? We implemented the solution also there where we detected it. That it's like it's worth the effort. Sometimes with like 1 packet per minute, which is affected by asymmetric routing, then it's not that like the customers maybe really detects the problem, because in our case we always have two clouds, so two name servers, two name server IP addresses, two clouds, and we never announce this both prefix from the same node. So even like if the customer is using NS2 and has a timeout, NS1 is always working, and the other way around, because they always have different routing policies. So that's why the reason why customers don't detect it so early, the problem.
Okay, thanks.
Guys, last question, then we need to move on. Sorry. Please, quick.
All right. Hi, Martin Pels, RIPE NCC. So we are solving this at the front by when an IXP comes to us that they want to host a node for us, we tell them we need a peer that provides us with a BGP full table or default route. So then we don't run into this issue.
Okay.
But I had a question. How do you deal with DDoS attacks? Because you mentioned that you're tunneling the traffic over your management interface. So if you get a lot of this traffic, you might saturate your management interface and you can no longer reach the box.
We have to, like for volumetric DDoS attacks, we're using Cloudflare as DDoS mitigation provider. So we have automation. So we're using NetFlow on the Anycast nodes. So that usually works, that we still receive even if the link is full, we can send out the net node packets, the NetFlow packets. So we detect it on our side and automatically activate Cloudflare. And once Cloudflare is turned on, it's really that they absorb like 99% of the traffic. And in that case, if Cloudflare would be activated, they give us the clean traffic over many exchanges, and then we could have the problem that would, like, if you activate your cloud DDoS mitigation provider, you have asymmetric routing by design. It's just a different way. So we could have potential really lots of packets which we would have to route into the GRE tunnel. That's why we have configured it in that way that Cloudflare send us the clean traffic only to our global nodes, not to the local nodes. So that way the GRE tunnel will not be saturated.
Okay, thank you.
Welcome.
Thank you, Klaus. Thank you very much.